Hey Jordan, you won't believe the research I've been reading. It's about using AI to manage home energy.
Oh, really? Like those smart thermostats? What's so special about it?
It's way beyond thermostats. It's a full-blown home energy management system, HEMS for short, but using Agentic AI.
Agentic AI? What's that even mean? Sounds like a sci-fi movie.
Okay, so basically, it's using large language models, LLMs, like ChatGPT, to act as autonomous agents. This system can coordinate all your appliances to schedule their energy use.
Wait, really? So it's like telling my washing machine to run at night when electricity is cheaper?
Exactly. But the problem they're tackling is that HEMS adoption is super low.
Yeah, I can imagine. It's always a pain trying to set those things up.
It's because current HEMS interfaces are terrible. People have to translate their everyday preferences into technical parameters. It's complicated, Nobody wants to spend hours figuring out the optimal settings.
Tell me about it. I tried setting up a smart plug once, and it was a nightmare. So what's the solution?
This research proposes using LLMs to make the whole process intuitive. Instead of messing with complicated settings, you just tell the system what you want in plain English.
No way! So I could just say, schedule all my loads tomorrow for minimal cost?
Precisely. The LLM acts as the brain, coordinating everything from your natural language request right down to the actual device control. That's wild.
Okay, that sounds amazing. But how does it actually work? Is it just one giant LLM doing everything?
Nope, it's a hierarchical architecture. There's one main orchestrator agent, powered by an LLM, that delegates tasks to 3 specialist agents.
Specialist agents? What do they specialize in?
Washing machine, dishwasher, and EV charger. Each agent is an expert in scheduling that specific appliance.
So the orchestrator figures out the big picture and tells the appliance agents what to do?
Exactly. And they use something called the REACT pattern. It stands for reason and act.
REACT? Sounds like a superhero thing.
It's a way for the LLM to iteratively reason about the task, decide on an action, execute it, observe the outcome, and then adjust its strategy accordingly. It's a loop,
Smart. So it's not just blindly following instructions.
Right. It can adapt to different user requests and system states without any hard-coded workflows. Plus, it integrates with Google Calendar.
Wait, what? Why Google Calendar?
To extract deadlines. The system can look at your calendar and infer when you need your EV charged by. Like if you have work in your calendar from 9 to 5, the system knows you need a full charge by 9 a.m.
No way! That's so cool. It's actually understanding my schedule.
I know, right? And it's not just about scheduling. The system has a multi-layer tool framework that unifies analytical capabilities, external API integration, and specialist agent delegation.
Okay, you're losing me again. What's a tool framework?
Think of it as a set of tools the orchestrator can use. It can fetch electricity prices from an API, query your Google Calendar, calculate window sums for cost optimization, call the specialist agents, and finally, schedule the appliances. It's all integrated.
So it's a pretty complex system. Did they actually test it out?
Of course. They evaluated it using 3 different open-source LLMs, Llama-3.3-70B, QN3-32B, and GPT-OSS120B.
Never heard of those.
They're powerful language models, like ChatGPT, but you can use them without paying. Anyway, the results were fascinating.
Lay it on me.
Llama-3.3-70B nailed it. It successfully coordinated all 3 appliances across all evaluation scenarios and matched cost-optimal benchmarks.
That's amazing. What about the other models?
QN3-32B and GPT-OSS120B struggled to coordinate all appliances simultaneously. They could handle single appliance scheduling perfectly, but multi-appliance coordination was a problem.
So it's not just about having a powerful LLM, it's about its ability to coordinate complex tasks.
Exactly. And they also found that explicit workflow guidance is necessary for consistent analytical query handling.
Analytical queries? What are those?
Like asking the system, what are the most expensive 3 hours tomorrow? The models couldn't reliably answer those questions without specific instructions on which tool to use and how to interpret the results.
Okay, I get it. It's not enough for the model to understand the question. It also needs to know which tools to use to answer it and how to process the information.
Yep. The models needed a little help figuring out how to handle those types of questions.
So what's the big takeaway from all this?
Agentic AI, HEMS, can achieve optimal scheduling performance and enable natural language-based interaction, which is a huge step forward.
That's awesome! It really could make home energy management accessible to everyone.
Exactly. But model selection is critical. You need a model that can handle complex coordination. Prompt engineering is also important to make sure the system can answer diverse questions.
Makes sense. So it's not a perfect solution yet, but it's a promising step in the right direction?
Definitely. And the best part is that all the system components are open sourced.
Wait, really? So anyone can use it and contribute to its development?
Yes, it's all on GitHub, including the agent prompts, orchestration logic, and web interfaces. They want to enable reproducibility and further development.
That's fantastic. I love open source projects.
Me too. I think this research could really help to address the configuration complexity barriers that currently limit HEMS adoption. It can also facilitate demand response and renewable energy integration.
So it's not just about saving money. It's about making our energy systems more sustainable.
Absolutely. And making it easier for everyone to participate. Imagine a world where everyone can effortlessly manage their energy consumption and contribute to a greener future.
That's a future I want to live in. This is some seriously cool stuff, Alex. Thanks for sharing.
No problem, Jordan. Glad you found it interesting.
Catch you later.
Thanks. Bye.